Welcome students. In this session of video lecture, we are going to discuss about scope of parallel computing applications. So where basically these parallel computing systems and servers are used basically practical use. So parallelism finds applications in very diverse application domains for different motivating reasons. So basically parallelism, that is parallel computing platforms, they find application in diverse application domains. Okay. These range from improved application performance to cost considerations. So why they are used is basically because they have a improved performance basically for the application. So applications perform better on parallel computing platform as compared to serial computing platforms. And also the cost considerations are better for parallel computing platform. So because some of these reasons, parallel computing platforms are used in vast domain of applications. So first is applications in engineering and design. So parallel computing platforms are used in engineering and design basically for these applications. So it is used in design of airfoils, optimizing lift, drag, stability. That means what? It is used in design of aircrafts. Whenever aircrafts get designed, they use parallel computing platforms. They are used in internal combustion engines. So the internal IC engines of the different vehicles. For the design of such vehicles, IC engine, the parallel computing platform servers are used for doing the designing of those vehicles engines. So they basically optimizing charge distribution, burn. So they are used for basically designing the engines of the vehicles in the automobile industry. Then they are used in high speed circuits. So designing of high speed circuits are basically done using parallel computing platform servers. Layouts for delays and capacitive and inductive effects are studied in the high speed circuits. Then they are used in structures, like in civil engineering. How the structures get designed, they also use parallel computing platforms. So basically optimizing structural integrity, design parameters, cost, analysis of those all structures and optimizing the designs of the structures is done on parallel computing platform. So you can easily see there is a vast domain of in which engineering applications parallel computing platforms are used. Then they are used in design and simulation of micro and nanoscale systems. So basically design of nanoscale systems, nanotechnology and micro scale systems. In design and simulation of such systems, parallel computing platforms are used. So basically mainly wherever you require a lot of computing and all those things, mainly there, that is where the engineering and design problems are used for basically parallel computing platform. Process optimization, operations research. So they are also used in process optimization and operations research. So in optimization problems, basically parallel computing servers and parallel computing platforms are used for basically executing such applications. Parallel computing platforms also find their use in scientific applications. So in scientific applications also parallel computing platforms are used. Functional and structural characterization of genes and proteins. So for basically analyzing genes and proteins, parallel computing servers are used for doing the computations of those applications. So in basically genes and protein study, parallel computing platforms are used. Advances in computational physics and chemistry have explored new materials, understanding of chemical pathways, and more efficient processes. So in advances in computational physics and chemistry also parallel computing platforms are used. They are basically used to find new materials in physics and chemistry, and understanding of chemical pathways how chemical reactions work. So study of that also parallel computing platforms are used, and more efficient processes. So to find out more efficient processes in physics and chemistry, parallel computing platforms are used. So in science, basically, applied science specifically, parallel computing platforms are used. Applications in astrophysics have explored the evolution of galaxies. So in astrophysics also, that is space research, parallel computing platforms have been used. So they are used for basically evolution of galaxies, thermonuclear processes, for nuclear reactions, also study of that, parallel computing servers are used, and the analysis of extremely large data sets from telescopes. So space research again, large data sets available from telescope, they are studied using parallel computing platform. See, remember, parallel computing platform, simple example can be supercomputer. You are having supercomputers used in big organizations, government, institutes. So they are basically running all these applications that we are discussing. Like for example, Indian CDAC has developed Param supercomputer. So that is being used in India basically for doing the parallel computing executions. Okay. So those basically supercomputers are examples of parallel computing platforms computers. Okay. They are not the only example, but they are one of the examples of parallel computing platform servers. Then in weather modeling, mineral prospecting, flood prediction, etc. are other important applications. So in weather modeling also parallel computers are used. In mineral prospecting, to find out minerals where they may be possible to find minerals in which part of the area of the land. For that study also parallel computers are used. In flood prediction, flood prediction is done on parallel computers. Okay, and other important applications also parallel computers are used. So basically in these basically supercomputers or parallel computing servers, they basically are used in, mainly this kind of things are done in government organizations of every country. This weather modeling, not necessarily limited to that, but it is one of the departments of government which do the weather modeling. So they predict whether the monsoon is going to be proper or not, how, whether there is any particular risk of any uh, storm or anything like that. So all this is done using parallel computing platforms. Bioinformatics and astrophysics also present some of the most challenging problems with respect to analyzing extremely large data set. So bioinformatics and astrophysics, they are one of the domains that are having lot of large data sets, and to analyze these large data sets, parallel computing platforms are used basically. Okay, so these are some of the applications in scientific applications of parallel computing platforms. Parallel computing platforms are also used in commercial applications basically. So in commercial applications also parallel computing platforms are used. Some of the largest parallel computers power the Wall Street. Wall Street means what? The stock exchange of United States of America. So the stock exchange of United States of America uses parallel computers to store the all data of its stock exchange. So whole Wall Street data is basically stored on parallel computers basically. Okay. Similarly, Indian stock exchange also parallel computers are used to store data of the stock exchange. So in various countries, parallel computers power their stock exchanges, data of the stock, because that's a very large amount of data. A lot of processing will be involved because the whole country and the world invests in the stock exchanges. A lot of data is being handled by the servers of the stock exchange. So they are basically designed using parallel computing platforms. Data mining and analysis for optimizing business and marketing decisions. These applications also use parallel computing platforms. Data mining means what? Extracting knowledge from data. So such applications also use parallel computing platform. And analysis for optimizing business and market decisions. So those analysis also are done by parallel computing platforms. So basically they are used in these applications also of commercial application in data mining and analysis. So mainly they will be useful in decision support systems. Suppose the company wants to take some decision, then it will analyze the data and accordingly provide inputs to the management for taking decisions. So these are basically useful in decision support systems in data mining and analysis. Large-scale servers, mail and web servers are often implemented using parallel platforms. So the parallel computing platform servers also power the internet. So the internet servers, the mail servers, the web servers are made using parallel computing platform. Maybe supercomputers or other parallel computing platform servers are used in internet as mail and web servers. So large scale servers are used as basically mail and web servers in internet. Okay. Applications such as information retrieval and search are typically powered by large clusters. So information retrieval and search are basically powered by large clusters, which are also example of parallel computing platform. So basically your search engines, they also use parallel computing platform servers for searching the internet and basically retrieving information from the internet. So they are also powered by high performance computing parallel platforms for basically doing the computation of the search and searching on the internet. So these are some of the commercial applications of parallel platforms. Then the parallel computing platform also find applications in computer systems. So in computer engineering also applications of parallel computing platforms are present. Network intrusion detection. Network intrusion detection means what? Any intruder has intruded the network or not. Detection of that, IDS basically. Okay. So intrusion detection systems use parallel computing platforms for doing the detection of intrusion. Cryptography uses parallel computing platforms. Cryptography means what? Encrypting data and decrypting at the receiving end. That also uses parallel computing platforms. Multi-party computations are some of the core uses of parallel computing techniques. Embedded systems increasingly rely on distributed control algorithms. So here also parallel computing platforms are used in embedded systems. A modern automobile consists of tens of processors communicating to perform complex tasks for optimizing, handling and performance. So modern automobiles also have a lot of processors in them. Okay. So they are also become a parallel computing platform. So it is also an application of parallel computing platform. Automobiles with multi-processors in the vehicle. So this is also another application of parallel computing platform. Conventional structured peer-to-peer networks impose overlay networks and utilize algorithms directly from parallel computing. So basically peer-to-peer networks that search on the internet, they are also using basically parallel computing for doing the search on the internet. So these are some of the applications in computer systems. So you can easily see parallel computing platforms are finding application in wide range of domains and are very popular in this age of computing. So they are basically used in very large domains and very large scope of domains. Okay. So thank you for attending today's video lecture. We'll continue in the next video lecture.